Learning target 1.6. I know atomic number and how it is organized in the periodic table. So I hope you can see this periodic table. If not, get out one of your own. But the periodic table has a lot of information buried inside of it. And if you know how to read it, you will be very, very good. You can be very, very good at chemistry because it has a lot of stuff in there that can be useful. Probably the most useful thing is atomic number. So atomic number is usually the biggest number in each of the squares. So let's just look at hydrogen right here. So I'm going to draw a picture of the hydrogen square. Okay, it has a big H. It has the name hydrogen. I'm going to write it right there. And then it has the 1 and then a decimal number down here. I think it's 79. Okay, so that's what it kind of looks like. The important thing to look at is this number right here. Okay? Just says 1. That is the atomic number. That is how the periodic table is organized. So if you can see, if you read from left to right like a book, the atomic number gets bigger. So here's 1. You go all the way over to here and you see 2. Helium. Okay? What do you do when you read a book? From left to right, you drop down to the next line. So when you drop down, you see 3. Then you go left to right, beryllium, 4. Boron, carbon, nitrogen, oxygen, fluorine, neon. And you continue going. And you can see every single time it's just going up by 1. What do these things mean? The atomic number tells us how many protons? The atomic number tells us how many protons are in an atom. Let me spell protons right. Okay, that helps us figure out how to organize these elements. So much so that some of these elements down at the bottom, I'm going to move it, down at the bottom, for instance, neptunium, plutonium, americium, curium, berkelium, all the way through nobelium, and there's actually lawrenciums on here. There's a whole bunch more. These are all man-made. And they are man-made because we can predict what these elements will look like, all because of this trend that we see. And the trend is these atomic numbers, increasing atomic numbers. They go bigger and bigger as we go along, so we can predict what the next one will have. So after nobelium, lawrencium, which is the next one you guys could guess, has 103 protons, and it was made right here in California. So it's kind of a neat way to organize a table. Mendeleev did it long ago, and it tells us how many protons are in an atom. That's the important thing to realize. Atomic number tells us how many protons are in an atom. For the individual example, I ask, an atom has a mass of 7 AMU and 4 protons in its nucleus. This element must be in Y. So pause the video here and try to figure out the answer on your own, and then check it with mine when you repause the video or unpause the video. Okay, so the thing to realize here is that is the information that the question gives you. The question gives you both the mass and how many protons. Then it asks us, what is the element? Well, we should remember that the atomic number tells us the atomic number tells us how many protons there are on the nucleus of an atom. Well, we know how many protons. We have 4. So that means 4 protons equals atomic number equals 4. 4! So what do? We have to look at the periodic table. So if you get out your periodic table and look up, you should see that the square that has the Be in it with the 4 on top, that's your answer. Beryllium. Beryllium.